In this video, we're going to continue our discussion of glycogen metabolism control. So glycogen metabolism in the liver is going to be largely controlled by the hormones insulin and glucagon. Both are synthesized in the pancreas in response to blood glucose. Insulin is made when you have high glucose. Glucagon is made when you have low glucose. That's kind of what the name means. Glucagon. Glucose is gone. All right. Now, muscles and tissues are controlled by insulin, epinephrine, and norepinephrine. This will stimulate phosphorylation by regulatory enzymes, and really all this is going to work via secondary messengers, which means these hormones are going to bind on the outside of the cell. When they bind to the outside of the cell, a different messenger is going to be released into the inside of the cell, relaying a message. So we're going to look at this piece by piece, and we're going to start with glucagon. And glucagon is released from the pancreas when your blood glucose levels are less than 5 millimolar. This can happen after exercise, after several hours after a meal has been digested. And this is critical that you have glucagon because it's critical to the liver's function of giving glucose to the tissues that need it. For example, your brain, right? Your brain can only use glucose. While muscle cells, they do not react to glucagon because they don't have the receptor. So what happens is if your blood glucose levels are low, pancreas will release glucagon. Glucagon will go and bind to glucagon receptors on different liver cells. When this interaction happens, these receptors will release cyclic AMP into the interior of the cell. This is your secondary messenger. Your primary messenger was glucagon. Your secondary messenger is cyclic AMP. This cyclic AMP will go and turn on the enzymes, pKa, that will break down glycogen like we talked about in the previous video. This glycogen will turn into glucose. This glucose will leave the liver cell through the GLUT2 transporter and will go to the tissues that need to use glucose for energy. Now, epinephrine and norepinephrine, these are your flight or fight hormones. That happens when you're stressed, as you might be as you watch these videos. Now, you have two different receptors. You have a beta receptor and an alpha receptor to interact with these hormones. Muscles only have a beta receptor. Liver cells have an alpha and a beta receptor. So epinephrine, when it's released from your adrenal glands, we're going to start with the muscle. It will go to your muscle, bind to the beta receptor. This beta receptor will release cyclic AMP, which will make turn on pKa, which will make glycogen be broken down, which allows your glucose to be used for glycolysis, so you can get energy when you have epinephrine. Again, you're stressed, so you want ATP around in case you need to flee or fight. Now, epinephrine will also go and bind to the pancreas. The pancreas will make glucagon, and the glucagon can go and interact with the liver. So that's indirectly how it can affect the liver. But it can also affect the liver directly. So it can either bind to the alpha or beta receptor. If it binds to beta, it will produce cyclic AMP, which will break down glycogen. If it binds to the alpha receptor, it will release calcium, which just reinforces this glycogen breakdown, as we talked about in the previous video with all our enzyme systems. Now, insulin is released if you have high levels of blood glucose, for example, after a meal. And insulin will increase the rate at which glucose is transported into many different types of cells that have insulin receptors or insulin-sensitive glucose transport, such as GLUT4. So insulin's released. So it can go to muscle and fat cells, that have the GLUT4. Liver and brain don't have the GLUT4. So what happens is that it will bind to the muscle, the insulin receptor. That will turn on GLUT4. It will also turn on glycogen synthesis because if you have a lot of glucose around, start storing your glycogen. We don't need more glycogen. And so it's going to decrease phosphorylation and glycogen synthase. In the liver, you have it bind to your receptor, and again, it will start the glycogen synthesis. It will also turn on certain glucose transporters in different cells, as we talked about, just not in the liver. That's it for that video. A little bit of a mess there at the end, but hopefully you got the picture, and I will see you in the next video.